Welcome back to Workplace and Apprenticeship 30. We're starting on Chapter 7, which is titled Trigonometry. In this chapter, we're going to learn about two different trig laws that help us solve oblique triangles. Now, oblique means a triangle that is not a 90-degree right triangle. We're going to use the sine law and cosine law to find unknown side and angle measures. You can start by reading Math on the Job on page 248. Then we're going to look at question 1. What is the size of angle B? So we know the other two angles of this triangle, so all three have to add up to 180. So if we go 180 minus our two known triangles, we're going to get 70 degrees. Now if each of these angles are 70 degrees, what type of triangle does this make? We know that this makes an isosceles triangle because it has two of the same angles. However, we're not actually going to use that information in this question. Question 2, find the length of AB and CB if the length of DB is 18. So we're going to start by angle 70 is in this corner. So opposite of angle 70 is 18. And we're looking for the hypotenuse. Looking for H. So to set that up, we go sine 70 equals your adjacent, which is 18, over your hypotenuse, which is side length AB. Multiply both sides by AB, and then divide by sine 70 to get AB by itself. So when we go 18 divided by sine 70, you should get 19.2 inches. Go ahead and try CB on your own. So you should have got CB equals 28. So we know that this side is 28. Now we want to figure out what the other side length is. You could do this really easily using your properties of isosceles triangles. So what should side length C or AC equal? What should side length AC equal if you're using isosceles triangle properties? 28, good. So we know it should be 28. Now I want to prove this using SOHCAHTOA. So the class here in St. Brood chose to use a squared plus b squared equals c squared because they knew that we had two side lengths and we're looking for the third one in a right triangle. So they ended up getting 28.2, which is very close to our 28, just some small rounding that would have made that difference. Now there is an easier way that we could have done this, because it took quite a bit of work there for us to find side length AC. So today we're going to explore the sine law, which would be an easier way of doing this. So we'll start by reading Explore the Math on page 249 and filling in the following definition. So there are the definitions. Now the sine law, it writes here as sine A over A equals sine B over B equals sine C over C. Now at any time, you only really need to use two out of these three things. Also, this could be, this also could be flipped and have all the small letters on top and all the sine A, sine B, and sine C on the bottom, and it won't make a difference as long as they're all flipped. Okay, so you need all the signs together on either the top or the bottom, and all the little letters together on either the top or the bottom. Something else to note is we always write angles in capital letters. And we always write the side lengths in lowercase. So make sure you're being consistent with this throughout. Now we use the sine law if there's two different cases. The first case is if you have two sides and one angle, but you need that one angle to be across from one of the side lengths. We're always looking for pairs here, and by pairs I mean ones that are across from each other. Case 2 is if we have two angles and one side length. So again here we have an angle and a side length that are a pair or are across from each other. You can also note that little a is always across from big A. So angle A and little a are always across from each other, so that would make them partners. So you always put those together. Also, in case 2, if you have two angles, you could always find the third in case you were given, say, a side length here that's 15, and you didn't have this 11, you could find your other angle so that you would have a pair. So let's try this in an example. We're going to find the length of B. So here we have big B, which would be our angle. Across from big B is little b. We also have another pair, which is angle A, which is this angle here. And across from that is little a. So there we've got a pair. As long as you have one complete pair, you can use the sine law. So here we're going to go sine capital A over small a equals sine capital B over small b. Capital A is 108 degrees, so we have sine 108. Small a is 24. Sine capital B is 33 degrees. Little b is unknown. Now I know everybody here can multiply or cross multiply, so that's exactly what we do. We just cross multiply. We'll get b times sine 108 equals 24 times sine 33. Make sure your angles are always stuck with the sine. Your little numbers would always go in front, or your side lengths. So now we're trying to get b by itself. So we're going to divide both sides by sine 108. And we can figure this out on our calculator. Make sure your calculator is in degree mode, or this will not work for you. So we're going to go 24 times sine 33 divided by sine 108, and you should get b equals 13.7. Okay, now double check that your smallest angle and your smallest side length should always be pairs. Also, your largest angle and your largest side length should always be pairs. So you can always check your answer by going 13.7, that is smaller than 24, and yes, that makes sense because 13.7 is crossed from the smaller angle. So that should be correct. Now there is another case. Here we're going to find an angle. So we're missing big B, but we have little angle B. We also have side length C and our angle C. So we'll write this in a sine law again. Sine C over little c equals sine capital B over little b. We have one pair, capital C and little c. We have both those numbers, so we can plug them in. So sine 45 over 35 degrees. Ooh, whoa, sorry. I'm already confusing everybody. Sine 35, because 35 is our angle, over our side length, equals sine B, because B is what we're looking for, over our other side length, which is 23. Again, we cross multiply, so you get sine 35 times 23, and that's equal to 45 times sine B. Now this is tricky to some people, but since we're missing our angle, our sine needs to stay with our angle. So we just divide both sides by 45. Then you get 23 times sine 35 divided by 45, and that gives you 0.29. So every single time you should get a decimal number that is smaller than 1. The reason for that is because then you need to hit your second or inverse button on your calculator. So you'll go second sine. That'll give you something that looks like this, sine inverse times your 0.29. That will give you the measure of your angle B equals 17 degrees. So go ahead and try these you-try problems on your own, and then we'll go through them together. You can check your answers here on the board. And then on the Moodle, I posted a sine law worksheet. You can work on that for your homework assignment today.